Good afternoon, everyone. I hope you had an excellent weekend and are enjoying the start to the week. We are going to, as promised, kind of pick up where we left off with a slight change of gears. Last week, of course, we did chapter 23, the digestive system, and learned about physical and chemical digestion and the role of enzymes, and ultimately transferring or converting food into monomers at the end of the day, which are the smallest of the organic molecule particles, carbohydrates, lipids, and proteins, small enough to allow for passage from the digestive system, specifically the small intestine, into the bloodstream and then circulation. So, what we're going to build off of this week is very much related. We're going to be talking today and Thursday about metabolism and nutrition. Today will be a little bit more on the nutrition side of it, looking at those big macromolecules, the carbohydrates, proteins, and lipids. And while a little bit of it will be familiar, as far as content goes, it might have somewhat of a feel like a little bit of a high school health class, nutrition class at times. We'll try to keep moving through the obvious things because there certainly are extra layers. Also, very important is we're going to talk about energy grabs and how the body at the cellular level starts to create ATP, and all of that is going to form the foundation for Thursday's lecture, which is going to be really important when we talk about metabolic pathways from a chemical standpoint and how we create adenosine triphosphate from nutrients that we have ingested, and those pathways such as glycolysis and the Krebs citric acid cycles, the electron transport chain, oxidative phosphorylation. So Thursday is going to be very involved. So absolutely don't miss Thursday's lecture. It's going to be more into the chemistry part of metabolism and the synthesis of adenosine triphosphate. Today might be a little bit of a repeat, like I said, some overlap to things you've heard before, but that's good. It's good to dust off those old synapses and refresh that knowledge in your mind, because you're going to see this content obviously on our coming exam. And like I said, there also will be some new layers that I'm going to add. So let's go ahead and get started with nutrition and metabolism. So nutrients. We talked about nutrients multiple times last week, right? The end game was the breakdown of physical food and beverage into nutrients that are small enough to pass from the digestive system into the bloodstream so they can be used out at the cellular level. Okay, and our nutrients are used out at the cellular level for any variety of activities. It could be for synthesis of proteins, for tissue repair, for example. It could be for energy. It could be for hormone production. It could be for mitosis. Our body and our cells, which when I say our cells, of course, I mean all tissues, organs, and organ systems, all require nutrients for all of the functions that they conduct. Okay, so nutrients are vital to everything. Okay, when we think of nutrients, we usually think again of the food and beverages that we consume, that we ingest, that we've talked about all of last week. But there are other things that are nutrients that our cells need, such as vitamins and minerals. Water is a nutrient, very, very vital nutrient that we talked about, is absorbed at 3 different levels of the alimentary canal: the stomach, the small intestine, and to a lesser extent, even the colon. So there are a variety of nutrients, and we're going to kind of touch on all of those today as we proceed through the first half of this chapter. Okay. Ultimately, again, the bottom line is we want to be able to absorb as many valuable nutrients from food, beverages, or vitamins that we ingest so that the body can use them. Okay, and most of them are absorbed at the small intestine level. And again, the major nutrients, the organic molecules, the big three are carbohydrates, lipids, and proteins. And we'll certainly talk a little bit about each one of those today. All right, like I said, beyond the nutrients that we eat and ingest and or drink, because of course we can take in nutrients from beverages too. Vitamin C is a huge nutrient within orange juice, for example, right? So it's not just food, it can also be beverages, okay? Like I said, water is a nutrient. It's a huge molecule required for the body because at the end of the day, we are about 2/3 water as living creatures, okay? So we're going to see a common theme here through today's lecture on nutrients, nutrition, and metabolism introduction. And that's that there are sublayers to a lot of these things, and nutrients is the first of those. Nutrients can get broken down into essential nutrients and then non-essential nutrients, okay? Our essential nutrients are nutrients that, as the slide says, we have to take in orally. We have to eat it, drink it, or bring it in via a vitamin supplement, okay? Our body can't create these specific nutrients, these 40 to 50 essential nutrients. Our body can't create it from converting another nutrient into that type, okay? Which brings us to non-essential nutrients. Non-essential nutrients then are very vital to our existence and to cellular performance and function. However, if we run short on a non-essential nutrient, our body, and usually it's our liver, can convert one type of a nutrient that we have a surplus plus of into a nutrient that we have a need for, okay? So for example, if we run low on glucose, which is a monomer version of monosaccharides of carbohydrates, if we run low on glucose, our body can convert fat to glucose, to carbohydrate. Okay, our liver can convert that. So it's technically a non-essential nutrient because we can take something else and replace it and convert it. Okay, and we'll be talking a lot more about that, you know, glucogenesis, gluconeogenesis, glycolysis, all of those things on Thursday when we really get into those metabolic pathways again, the conversions that our liver can do from one nutrient to another to supply metabolic pathways in the chemical generation of ATP. All right, so let's get into carbohydrates, lipids, and proteins. All right, so carbohydrates, we all know what carbohydrates are, okay? They come from our diet. We usually think of carbohydrates as fuel sources, right? If you carb load, you're taking in a lot of carbohydrates to give you energy, maybe for a sporting event the next day, for example. But there are two different primary types of carbohydrates. The first ones are sugars, and then the second ones are starches. Okay, and we talked a lot about starch type carbohydrates when we talked about the gastrointestinal system, right? And how the enzyme amylase works on breaking down starch type carbohydrates as early as the oral cavity. Okay, starches are typically our good carbohydrates. Okay, if you will, and I'm just going to share up front with everything related to nutrition. It goes back to the old adage that we probably all have heard most of our lives, that when it comes to the human body, everything in moderation is a great rule, okay? Too much, excess of anything can be harmful, okay? And that's really where I want to introduce sugars. Sugars are technically a kind of an empty calorie, Okay, they're useful, but they're potentially dangerous, and we'll talk about those in a minute. Why that is, okay? But but sugars are again a byproduct of the monosaccharides, those monomers of carbohydrates other than starches. If they come from fruit or from honey or from milk, they're generally pretty good and in limited amounts, moderation. Okay. But if we're taking in processed sugar, the true sugar like we think of when we think of sugar, like from chocolate cake or from candy bars or from ice cream, you know, those type of sugars are truly typically empty calories that are very, very high in energy potential. And because they have such a high caloric value, they have a high likelihood of being converted to fats. Okay. And first of all, right now, let me talk to you a little bit about what is a calorie. Okay. We talked about, well, you should eat 2,000 calories a day, or you burned 250 calories on the elliptical machine at the gym. Okay. A calorie is just a measurement. Okay. It's a measurement index, just like a degree is if we're talking about temperature outside. Okay. A calorie is a measurement of the energy potential of a given food. Okay. Or activity. If you burn 250 calories, you burned 250 energy potential units that came from your diet. You use those in order to exercise. If a candy bar has 350 calories, it has 350 degrees, if you will, of energy potential. Okay. Now our food varies, as we all know, a lot in calories, okay, and in calorie values. Something like a carrot may have 15 calories. It doesn't have a tremendous amount of energy potential. And by energy potential, I mean what we're going to focus on and talk about at length on Thursday about the metabolic pathways of converting calories, nutrients, into ATP. And if you remember, ATP, adenosine triphosphate, that is the fuel that provides energy for all of our cells, tissues, and organs. Okay. If we were a car, ATP is our gasoline. Okay. So these nutrients can be used for a variety of things, but the first and by far the most important thing that nutrients are responsible for is providing ongoing energy, the conversion to ATP, so that all of our cells can continue to function. Okay. So when I talk about energy potential, I'm talking about how much energy could be extracted in a metabolic pathway to convert those nutrients. Even sugar can be converted to ATP. Okay. But in one of the metabolic pathways, how much energy could come from that nutrient? That's what a calorie is. Okay. So where we run into trouble is, again, if we have a carrot that has 15 calories and we have a candy bar that is 350 calories. Again, back to everything in moderation. If you have a Snickers bar once every 2 weeks, that's very moderate, right? Your body is probably going to just go ahead and burn those calories, use those calories in its day-to-day function, and you'd probably be fine. But if you had 6 Snickers bars every single day, you're taking in excess of these very high calorie count sugars that, because your body's not going to use all of that energy unless you were an Olympic athlete, for example. But most of us aren't going to be able to burn that many calories. We don't use that many calories in our day-to-day activities. So then those sugars that are so high in energy potential, so high in empty calories, will get converted to fat and stored as adipose tissue. So that's the literal why junk food, sugar products become fat in most people. Okay, they're high in calories and it doesn't take much to overdo it. And then what we don't use, we store, and we store it as fat. Okay, so all right, then we have fiber. And fiber is something that a lot of people think of when they think of carbohydrates as well. And fiber is a good thing. There's a lot of hype in the news and on infomercials and in health products about get your fiber, right? And there are two different types of fiber. Both are good. Fiber has a lot of valuable contributions to the human body. Okay. What we typically are thinking of when we think about fiber are the insoluble fibers. Insoluble, meaning that it can't easily be broken down or liquefied, okay, physically or chemically digested. Okay. These are the things that come from roughage, like lettuce and salads, okay, from a lot of our grains provide some roughage. Okay, these are all really, really important, and they tend to remove harmful things from our body. Fibers do. Oatmeal, for example, is a great source of fiber. Okay, and because oatmeal will latch onto cholesterol and bind to it and pull it out of the body and eliminate that harmful cholesterol with the oatmeal. Oatmeal at the same time, just like salad and roughage in our intestinal tract, will actually act as a cleaning agent because it is physical roughage that isn't digested. So it's rubbing on the walls of our large intestine and helping to clean things out. Okay, so that's where fiber is really, really important, and specifically those insoluble fibers. The soluble fibers are things that we don't typically think of when we think of fiber, and these are chemicals. These are soluble. They can be liquefied, okay? They come from fruits typically, and these type of fibers get into our bloodstream and again, bind to harmful things like cholesterol and help to extract it from the body. So there's a couple of different types of fiber, okay? So again, primarily our starches come from plants, grains, and vegetables. Sugars come from either refined sugar, that junk food sugar, like in candy bars, or sugar definitely comes from things like fruit and beets and honey and milk. Okay, those aren't as high in calorie content as refined sugar is, like we find in desserts. All right, so this slide, I'm going to take a couple minutes on this slide and I'm going to kind of preview and explain some things that are really important conceptually when it comes to metabolism in general and things that foundationally we're going to be talking about not only today, but really talking about on Thursday when we get into metabolism and the creation of ATP. Okay, so carbohydrates. The very first thing that carbohydrates, when they're digested into their monosaccharide version, they're going to become glucose, okay? Glucose is our blood sugar, okay? You hear of your blood sugar levels, right? And if your blood sugar gets too high, you could be diabetic, right? And if your blood sugar is too low, you could be hypoglycemic, okay? And that's where we get into our endocrine system and the pancreas with insulin and glucagon coming in to balance out blood glucose levels. Our glucose, our blood sugar level, in other words, our digested carbohydrate levels in our bloodstream are absolutely vital to life because the very first thing our body and our cells need energy. They need ATP. Our cells are not good at storing ATP. They can't store a lot of ATP or reserve energy. So they're constantly reaching out and grabbing to make more ATP to keep themselves functioning. the first grab for our cells to make ATP is glucose or blood sugar. Okay, that's the first source of energy that our body tissues, organs, and cells reach for is blood glucose. And that's why our blood glucose levels, blood sugar levels, are so vital. Okay? When we eat and we take in carbohydrates, our body first, these carbohydrates are going to get converted to a monomer, and those are going to become glucose molecules. Once our blood glucose level is filled, it's at a normal, healthy measurement, okay? Any additional carbohydrates that we've taken in from our diet will get stored as glycogen, okay? Glycogen is just glucose that we've ingested from our food or beverages beyond what our body needs right now to top off the tank to fill up normal levels of blood glucose. Because again, our cells are going to grab for glucose in our blood first to make ATP. And then when those glucose levels circulating in our bloodstream start to get low, our body is going to reach out and convert that stored glucose, glycogen, that reserve capacity. It's going to convert that glycogen back to glucose again and burn it next. Okay? So glucose is circulating in our bloodstream, immediate power grab to make ATP. Glycogen is stored excess glucose that can very rapidly be converted back to glucose when we need energy. Okay, so that's the first layer of energy grab to make ATP. So glucose is our primary energy source. Okay, and there are some cells that absolutely need glucose to survive. Things like our neurons from our nervous system, our red blood cells, those erythrocytes, okay, they need glucose in order to survive, in order to perform their functions, okay? The second grab, if our body, let's just say that we're going on a long run, okay? Let's say that we're an athlete who runs a marathon. Let's use that as our example. All right, so once we start running that marathon, we're immediately going to burn through our glucose. It's in our bloodstream. Then we're going to start breaking down our stored glucose, which is glycogen, converting it back to glucose and using that for ATP to fuel our leg muscles while we run, right? Once we get done with that, the next grab for making ATP, and this is why I said these layers are important to understanding the foundation for what we're going to talk about on Thursday. The next grab of our cells for ATP is going to be lipids, fats, okay? And lipids or fats, if you remember back to Bio 210, we talked about tissue types, right? Adipose tissue was stored triglycerides. It was stored fat cells, all right? And roughly, and this is a rough measurement because everybody's different depending on your overall physical condition, your age, the speed of your metabolism, and even the amount of physical activity that you're doing. Roughly 20 minutes into exercise or 20 minutes into physical activity, if you're working in your garden, is when we will deplete our blood glucose and stored glycogen counts. Okay, about 20 minutes. That's how much energy for activity we can fuel our body with. And then at that point, we're going to convert from carbohydrate burning to making ATP to fat burning. And that's why when you see fitness recommendations, the USDA and fitness councils recommend that we exercise for 30 minutes a day, 4 days a week. Okay, the reason for 30 minutes is, and this actually contributes to a lot of things that you see when people are trying to lose weight and can't quite lose weight. This is a big reason why. If you get on the treadmill for only 15 minutes, yes, you're burning calories, but you're inside of that 20-minute window. So really all you're consuming when you're on the treadmill for 15 minutes and your goal is weight loss, eating up fat, stored adipose tissue, all your body's going to consume is your circulating glucose and glycogen. You're never going to touch your fat cells. It's not till about 20 minutes into exercise that your body will shift gears, shift sources for ATP production. And from 20 minutes on, then your body will start to break down fat cells to make ATP. And that's where you start to lose body fat as you work out. And that's why the recommendations recommend 30 minutes so that you're always burning some fat cells, because typically, especially as Americans, we're very blessed. We have very rich diets for the most part, and we typically take in more calories than we need, right? So we have stored adipose tissue, all right? So that's fats. That's the second layer of ATP energy production that our cells are going to grab for. And then third, and the last grab, and we want to avoid this at all costs, the third grab would be for our cells if they have exhausted the glucose and glycogen at about 20 minutes. Then, let's say, again with our analogy of being a marathon runner, that we're exceptionally low body fat, okay? We're one of those marathon runners that is extremely thin and has 2% body fat, okay? They're going to quickly burn through their glucose again in 20 minutes or so. Then they're going to burn through their fat cells because they only have a very, very small amount of stored fat. And then what do they do from there? The muscles of the legs still are running for 20 more miles, right? So what's going to happen then is if we get to that third layer, that's the unhealthy layer, they'll start to actually cannibalize, start to eat their own tissue, protein, okay? And protein isn't stored. Protein just exists, it circulates, and then the body and our cells will actually start to eat healthy protein tissue. And what is healthy protein tissue? Muscles and organs, right? And we don't want our body to start eating our organs. So that's where an example of people with severe anorexia and bulimia, when they get into serious life-threatening consequences, they're not ingesting any calories or extremely few calories, right? Because of the condition of their disease, okay? So they don't have a lot of glucose to begin with. So it may only take 5 to 10 minutes and they're out of glucose. They have exceptionally low body fat. They have 1% body fat. So there's no fat to grab for energy. So they're in that situation going to start eating healthy tissue. And that's the cannibalization, eating their own organs for fuel. So the body is literally consuming itself to keep itself alive. And that ends up being the fatal markers for many people with end-stage anorexia and bulimia. So all of those examples are the 3 layers of energy grabs nutrient-wise. Carbohydrates, roughly 20 minutes, then fat, then protein, and we want to avoid that at all costs. Okay? All of that's going to be foundational to what we're going to talk about on Thursday. All right, from a dietary perspective, how many carbs should we take in on a daily basis? This fluctuates, as all of them do, okay? Again, if you're a 95-year-old man who is retired and sits and watches the news all day, and your metabolism is extremely slow because you're older and not very active anymore for any variety of reasons, your recommended intake of carbohydrates is going to look very different than a 20-year-old Carolina Gamecock basketball player, right? So all of these are just estimations based on our body size, our activity level, our metabolic rate, etc. But as a general rule, around 50% of the total calories that we consume should come from carbohydrates. Okay. Now, these are a further breakdown of types of carbohydrates or labels on carbohydrates. We have the good carbohydrates, again, and we've mentioned these before, the grains and vegetables, even fruits, okay, are what we call complex carbohydrates, okay? They're the good carbs, and that's what we ideally should be consuming. It's the simple carbohydrates, the sugars, the processed sugars that are candy bars and chocolate cake and soda pop. Those are the things that we should try to avoid, okay? Because they're so high in caloric value, energy potential, it's very, very easy to overconsume them, and what we overconsume will be stored as adipose tissue, i.e. fat, okay? Again, we're very blessed in America and in most Western diets that we have easy access to carbohydrates, things like rices, pasta, breads, grains, vegetables. We typically don't have a problem finding those things. And this is a blessing and a curse. Remember what I said, keep that in mind about everything in moderation. Carbohydrates of the macromolecules of the nutrient types, carbohydrates, lipids, and proteins. Carbohydrates is by far the least expensive, okay? You can eat rice and pasta and bread a lot less expensively than you can steak or pork chops or crab legs, right? So where that comes into play is that for our lower socioeconomic demographics that are on an extremely tight budget and yet have a family to feed, carbohydrates tend to make up an excessively high, an excessively high percentage of their diet, okay? And when you take in too many carbohydrates, they lead to health impairments, okay? And that's the correlation between socioeconomic status and mortality rates and disease acquisition, etc. Okay, it usually has to do with being on an extremely limited budget and not being able to buy healthy foods. Now, I maintain, only because for 2 years I got coaxed into trying vegetarianism about 8 years ago when my youngest daughter was still at home. And I agreed to try it on a little bit of a health kick, and I made it about 1.5 to 2 years, and that was it, because I was hungry all the time, okay? But one thing I did take away from that experiment in my life is that our vegetable purchases at the grocery store were extremely inexpensive, okay? So even for families and people who are on a very tight budget, vegetables are extremely inexpensive, and you can buy vegetables even in a low socioeconomic situation just as cheap as you can pasta, bread, and rice, which are higher in calories and lead to obesity and other diseases, okay? So again, there's counterpoint to a lot of these different things. All right, first of your 2 quiz questions today, because we're going to split this chapter up. What is the first grab for fuel, for ATP production by our cells, our erythrocytes, and our neurons in our body? What's the first thing they grab for if they need more ATP for energy? All right, let's continue. Let's progress into lipids. And we won't take as much time with these because, like I said, we spent a lot of time on carbs when I talked about the different foundational levels of where our body and where our cells reach for fuel sources, okay? So triglycerides, we talked about that, right? As fats. Okay, triglycerides, the fats that we ingest in our food, are either saturated fats or they're the unsaturated fat variety. Okay, saturated fats are the quote unquote bad fats, even though, again, keep in mind what I've said multiple times now, everything in moderation. We do need fat in our diet, but to a limited extent. Okay, so our saturated fats come from meat and cheese, eggs, oils, those things that, and everybody's done this at one stage or another, or at least seen this. If you have a hamburger or you have a steak the night before, and you just don't have it in you to do the dishes that night, so you set your plate in the sink, and in the morning you come back to wash that plate, and the fat that was on that plate from that red meat has now become a white paste-like substance, right? Those are the saturated fats. Those are bad fats. Saturated fats turn semi-solid at room temperature. So that's what you're seeing on your dishes if you don't wash them overnight. Okay. By comparison, unsaturated fat like olive oil, if you put olive oil onto a plate and put it in your sink, it would still be liquid a week from now. Okay. Unsaturated fats are our good fats. They come from nuts and seeds, olive oils. Okay. Those are the more healthy of the two type fats. The big rap on saturated fats is that they are very high in cholesterol, and excess cholesterol in our body contributes to cardiovascular disease risk. Okay. Too high of cholesterol in our blood contributes to the buildup of plaque, the buildup of blockages in our carotid arteries and in our coronary arteries, like we discussed in the cardiovascular unit, that lead to heart attacks and strokes. Okay. So that's the big rap on saturated fats, the big negative aspect of it. All right. Now we know that when we mechanically or physically digest our food and then chemically digest it, we're going to break these fats, our triglycerides, our lipids, down into their monomers. And there are two of them when it comes to fats, if you recall, either fatty acids or glycerol. Those are the two monomers that are small enough to pass through the small intestine into the bloodstream. Okay. And then fatty acids and glycerol can be used as that second grab, like I described previously, when our body needs ATP and has run out of glucose. Okay? All right. Interestingly, when it comes to cholesterol, okay, and I've dealt with hundreds and hundreds, maybe thousands of people back when I was in practice in cardiology, talking to them about having high cholesterol and the cardiovascular risks and considering starting a statin drug to lower that cholesterol. The first thing they offer is, oh my gosh, I'm going to completely change my diet and I'm not going to eat pizza anymore and no more cheeseburgers, and I'm going to eat only fish and lettuce, and all of that is great. And this is not to downplay that in any way, shape, or form. If you have high cholesterol or any disease process, eating in a more healthy manner is always a good idea. It always leads to improvements, okay? But when it comes to your cholesterol that you have in your bloodstream and your measurement of cholesterol, 85% of your cholesterol is genetic in nature. It's made by your liver. It's predetermined by your parents and your ancestors, okay? Only 15% of your cholesterol, that bad fat circulating in your blood that leads to heart attacks, comes from your diet. All right. So again, like I said, making changes is definitely good because lowering that 15% is huge. It's tremendously important. But remember, it's impossible to lower your cholesterol by diet alone. 85% is genetic in nature, okay? And I'm an example of that. My parents, my grandparents, all had elevated cholesterol. Despite being an athlete in college, and I've remained athletic my entire life, I still work out 4, 5, 6 times a week sometimes, okay? So I've worked out my entire life. And yet, I've had high cholesterol or borderline high cholesterol since I was 18 years old. That wasn't because of my diet, or because of a lack of physical activity. It was because of my genetics. All right, so fat, like I said, there are valuable uses for fats, for lipids, in moderation. Again, so when we have an excess of consumed triglycerides, lipids, they're going to be stored as, if they're not consumed as energy, they're going to get stored as adipose tissue, as fat tissue, right? That we talked about in Bio 210. Adipose tissue, fat tissue, has value, okay, to a limited extent, moderation, okay? That adipose tissue provides a cushion for our organs, protection, insulation when it's cold outside. If you live in an extreme northern climate, having extra fat in the winter months keeps you warm, helps you to survive those harsh conditions that you're around. But most of all, adipose tissue is a tremendous source of potential fuel storage, energy reserve, okay? Glycogen is stored glucose. It's burned very fast, though. Fats, and you can see this is underlined, so really important to understand. If you compare fat, adipose tissue, to gram for gram next to carbohydrates, next to protein, fats have more energy per gram than any other of the organic nutrients, and by a long shot. Okay, so that means once we break down fats, they have the most stored energy chemically than any other nutrient. Okay, so they're a tremendous source of stored energy. Okay, all right, then we have fats that are in things that you talked about and learned about in Bio 210 and Bio 211, right? Our axons, our nerves, those myelin-coated sheets, that myelin is made of fat. Our plasma membranes of our cells, our phospholipid, they're fat in nature, right? So some good uses again. Muscular contractions, inflammation, those processes are regulated to some degree by circulating fats, okay? Some of our hormones, some of our vitamins require fats to bind to them in order to become effective. Okay, so fats, people, as soon as they hear the word fat, there's a negative connotation. But again, everything in moderation. We need lipids, we need fats in our diet. It's only when we take in too much that we get into trouble. From a dietary perspective, roughly 30%, roughly 1/3 of your diet should come from fat calories, okay? The saturated fats, the bad fats, should be restricted to 10% or less of your total daily intake of calories, okay? And cholesterol, those really bad fats, like from oils, are not required at all in our diet because, again, our liver makes 85% of our cholesterol, and ideally, we want to restrict it and keep the intake of cholesterol, saturated fat, as low as possible, okay? Especially if you're borderline or have high cholesterol or if you have cardiovascular disease. Moving on to proteins, and we all know what proteins are. Proteins are meat, eggs, fish, cheese, dairy, okay? Very, very important for tissue synthesis, right? Building tissues, all right? A lot of our grains, like soy, soybean, okay, and other grains have protein in them. Okay, a lot of legumes, lima beans, black beans, ranch beans, all those cannellini beans, all of those beans have proteins in them. Okay, so it's more than just meat, eggs, and fish. If you remember, proteins as the macromolecule are chemically digested in the stomach with the enzyme pepsin down into their monomers, which are amino acids. And if you remember, when we talked about amino acids, I said there are a variety. There's a lot of different types of specific amino acids, but amino acids as a whole are what the monomers of proteins are. Well, this is where we'll go a little deeper into that. There are 20 different specific types of amino acids, and it just has to do with their chemical composition, okay? However, of those 20, only 8 of our amino acid protein monomers are absolutely required, essential for our survival, okay? Those essential 8 amino acid types are considered complete proteins. Okay? Complete proteins are proteins from food that have all 8 of the essential amino acids in them. Anything else that only has, for example, 4 or none of the essential amino acids are called incomplete proteins. These are things like grains and nuts and soy. Okay, and this is where people that are vegetarian and vegan can sometimes get themselves into trouble. They say, you have to watch if you're vegetarian or vegan to make sure you're getting enough protein so that you can continue to generate new tissue, right? And for vegetarian and vegan individuals, it's very important to count your protein and make sure you're consuming it. Many of them will respond, well, I'm getting plenty. I eat soy-based products all the time, and I eat, these cashews and pistachios and peanuts and grains. I'm getting plenty of proteins. But the problem is they're not ingesting complete proteins that have all the necessary amino acids. So that's where sometimes they'll run into trouble health-wise. It's a fine balance. All right, so proteins, as I said, we use proteins that we've ingested, food or beverage wise, for structural repair, mitosis, tissue repair when we have an injury, growth if we're still young and still growing, okay? Replacing skin. Constantly, our skin, our epidermis is going through mitosis and generating new layers, right? So the structural building of our body, tissues, cells, organs, is all generated because of proteins that we ingest. Okay, then we have molecules like enzymes and hormones, things that I mentioned already, that also are protein in nature. Very, very important. When it comes to how many grams of protein or what percentage of our diet calorically should be a protein, the dietitians kind of take a cop out in that it's a little more clear that roughly 50% of our daily calories should come from carbohydrates. About 30% should come from fats. And then proteins, they kind of say it depends on your age, your body size, your metabolic rate, your physical activity levels, your health, etc. But the general rule of thumb is around 1 gram of protein consumed for every kilogram of body weight, okay? Again, we're very blessed in the Western world, America in particular, in that our diet, typically, we don't have shortages of protein. We typically don't run into protein deficiencies here in the United States. Second of your quiz questions for today. So which of the following nutrients has the highest potential energy, stored energy capacity for making ATP when it's broken down? All right, let's continue and finish up the lecture for today. All right, I told you we're going to talk about other nutrients beyond food and beverages. We'll just touch very briefly on vitamins and minerals, one slide on each, I think, and then we'll move into metabolism. All right, so vitamins, these are nutrients in every source of the word. They're organic in nature. They combine with our macromolecules, those carbohydrates, proteins, and lipids, in order to be more effectively utilized or absorbed. Okay. They can, vitamins work as coenzymes, meaning that they bind with other macromolecules like proteins, for example, to make them functional. Okay. So most of our vitamins are absorbed, okay, either from food, beverage, or a vitamin supplement, a daily multivitamin, for example. Okay. You can get all of your vitamins and minerals, for the most part, that you need from a daily multivitamin. I've taken one my whole life. I think it's a very inexpensive health insurance policy, about $8 every 2 months for vitamins, and it makes up for any deficiencies that I might have in my diet. I make sure my cells have everything that they need, vitamin and mineral wise. Okay. So most vitamins are ingested. The same with minerals. But with vitamins, there are some exceptions. Vitamin D is an interesting one. Vitamin D is absorbed from sunlight through our skin. Okay. And this is where people that live in the north, where I grew up, where it's largely overcast from October through April, winter, fall, a lot of cloud cover up there. We don't, back when I grew up, and it was cloudy when I lived there were a lot of people that had what was called seasonal depressive disorder. Vitamin D is an important vitamin to ward off our sense of depression, our sense of well-being from a mental health standpoint. Okay. And if we're not exposed, we don't have skin contact with the sun, we don't tend to absorb as much vitamin D during the winter months. So it's real important when you lived in those climates in the winter months to take a daily multivitamin or a vitamin D supplement to ward off those detrimental, harmful effects of seasonal depression. Things like vitamin K and vitamin B come from those intestinal bacteria that exist in the large intestine that we talked about. Things from vitamin A being converted from carrots, that beta carotene converted in the body and the liver. Okay, so there are some exceptions to the rule, but most vitamins and minerals come from our food and our beverages. And know that no one food group contains all of our vitamins and minerals that we need to remain healthy. Okay, carbohydrates, proteins, fats. That's why from the USDA, they recommend a balanced diet. All right, minerals. There are only 7 minerals that we technically require at moderate levels, at least. And these are the enzymes and minerals, the molecules that we've talked about throughout Bio 210 and Bio 211, things like calcium and sodium and potassium and chlorine. Okay, remember the sodium potassium pump that's responsible for shifting the electrical gradient to allow for muscular contraction. Okay, but if you didn't have sodium and potassium, you couldn't move those ions around and your muscles couldn't contract, right? So you'd have a problem. So there are 7 primary minerals that we need. These are the ones, again, that you've heard of time and again in anatomy and physiology. There are others that are required, like zinc, things like aluminum, things like that we need only microscopic amounts of, but they're still valuable, okay? And minerals like vitamins couple up and work with other nutrients to help them to function and to ensure our cells are functioning well. Okay, some examples of minerals. Calcium, again, is very, very obvious, right, when it comes to bone growth or bone repair if we have a fracture, right? Iron, we learned all about iron when we talked about hemoglobin being that component of erythrocytes. That hemoglobin has that magnetic-like reaction or relationship with oxygen molecules. Well, you can't have hemoglobin without iron. Okay. When we talked about the endocrine system, we talked about the thyroid hormone or the thyroid gland and its associated hormones being responsible for metabolism, right? And we're going to talk a lot more about the thyroid gland on Thursday. Okay. But the thyroid and its hormones maintain a healthy metabolism. And iodine is an absolutely essential mineral to the thyroid functioning properly. Okay, so those are some examples of uses of minerals in the body, and there are certainly others. All right, a brief introduction of metabolism. And again, this is going to be foundational and important for what we build on for Thursday. So don't go anywhere. We're almost done, I promise. Okay, typically when we think of metabolism usually people consider, in my morning class, which was live this morning, they said it's the consumption of calories. It's burning it's burning your calories. It's burning fat. It's using calories so they don't get stored as fat, right? And that is true, but that's only 50% of what metabolism is, okay? Metabolism are all chemical reactions of involving nutrients at the cellular level, okay? And like I just got done describing, utilizing those nutrients that were ingested from our food and beverages and vitamins is one component of metabolism, but then creating those organic molecules is the second part of metabolism. So that's where we get into two different terms that together truly equal metabolism. Okay, we have catabolism, and that's when we break something down. Okay, this is chemical digestion. Okay, protein reaching the stomach, and now there's pepsin there, right? And that pepsin, that enzyme, is going to have a biochemical reaction with the protein that's our piece of steak that we've eaten. And it's going to chemically break that protein down into its monomers, amino acids. That's catabolism, taking a protein and metabolizing it, catabolizing it, breaking it down, making it smaller. Anabolism then is the opposite of that. It's taking out at the cellular level, and remember I alluded to this several times in our lectures, that once our macromolecules from food, carbs, lipids, and proteins, are broken down to monomers and they pass into the bloodstream, once they get out to the cellular level, I mentioned that many times they'll be reformed, they'll synthesize back into the original organic molecule, from monomers back into proteins, carbohydrates, and lipids. They can get larger now again. That's anabolism. It's the rebuilding of smaller particles into a larger particle due to a chemical reaction, taking those amino acids and joining them together to make them into a functional protein again for tissue repair. Now, important for your exam, understand and know that when we're talking about metabolism, we have a base rate, a resting, sometimes called a basal metabolic rate, okay? That metabolic rate is the number of calories that at rest our body will consume, that it will consume or use X amount of calories on a daily basis just to keep our body alive, okay? So if you had a day where you just woke up and said, I'm not even getting out of bed today, I'm just gonna lay here and stream Netflix all day, even though you wouldn't be out walking around campus or going to the gym or working in your yard, even if you remained sitting in bed all day, you still would burn, 1,500 maybe calories a day, just because all of your cells are still going to be active, right? Your heart's still going to be contracting, your lungs are still going to be moving, all of your cells are still doing their work. So you're still burning calories. And that's what the resting or basal means base metabolic rate. How many calories will you consume just to maintain life? Then we can add our activity levels and you'll know the total number of calories that you consume, okay? But know that that hormone that we talked about back in endocrine system, way back at the onset of our course, thyroxine, that worked on the thyroid gland, that hormone was largely responsible for metabolism and the rate that we consume calories from our nutrients. That's the driver of our base metabolic rate. That should ring true and refresh your memory. All right, this next slide is exactly what I just said, and it's literally the examples of anabolism versus catabolism. As a study tip and trick to keep the two separate, at least this works for me. If not, you guys can find your own way to remember it. But to me, remembering the difference between anabolism and catabolism is that when I think of anabolism, what do bodybuilders, competitive bodybuilders sometimes take to make themselves grow from small into exceptionally large? They take anabolic steroids, anabolistic steroids, anabolism, okay? They were small and they're making themselves very large. So that's what helps me to remember that anabolism is taking small molecules and making them large, and catabolism is the opposite, taking a large molecule and making it smaller. All right, one of our last slides, but an important one. So when we process or digest or metabolize nutrients, okay, all three mean the same thing essentially, okay? There are three primary stages. And last week, we spent the entire week talking about the digestive system exclusively at stage one. We talked about the digestion of nutrients, both physical and chemical. We talked about the absorption of those monomers once they were to their smallest molecular size through the small intestinal wall into the bloodstream. And then we talked about the transportation of those monomers throughout from the circulatory system out to the tissues, right? So we cover this at length. Stage 2 and 3 is what we're going to talk about exclusively on Thursday. So I don't expect 2 and 3 to make sense to you today. Okay, so don't feel like you're missing something if this doesn't make sense today. We're going to talk all about this in detail on Thursday. But this is true, the metabolic pathways. And what does our body, our cells do with the nutrients, okay? And stage 2, this is an introduction. This works at the stage 2 and 3 are out at the cellular level, first of all, okay? And this is metabolism. All right, so stage 2 occurs in the cytoplasm. Remember, that's that liquid-like gel inside that plasma membrane that holds all the organelles and gives the cell its shape, right? So stage 2 occurs in that cytoplasm. And this is where those monomers can be resynthesized. They can go through anabolism and go from a amino acid and be resynthesized into a full protein for the purpose of tissue repair, okay? Or they can go from a glycerol and be reestablished into a triglyceride, okay? So that's synthesis, the building up of nutrients back into those organic molecules that they were before chemical digestion, okay? And then, of course, the opposite is catabolism. This is where we're going to further break down glucose, that carbohydrate monomer, in a process that's called glycolysis. And during the process, and that's a metabolic pathway to make ATP, And we're going to talk about glycolysis over and over on Thursday. But this is where glucose is that first grab for energy, for ATP production. The process is called glycolysis. It occurs in the cytoplasm of the cell. And the output is you had glucose, and now you're going to have pyruvic acid and acetyl-CoA, okay? And the production of ATP, okay? But only a tiny little bit. And then if that ATP produced in glycolysis isn't enough, only roughly 15 seconds to 30 seconds worth of energy is going to get produced from glycolysis. If you're out for a run, you need more than 15 to 30 seconds of energy. So then our body is going to shift gears. And now we're going to go on to stage 3. And now within the cell, we're moving from the cytoplasm, and now we're moving into the mitochondria. And remember, the mitochondria was that organelle, the mighty mitochondria, where ATP is produced. Okay, it's that ATP factory of the cell. Okay, and this is where different enzymes and things like the pyruvic acid and acetyl-CoA, along with other products, are all going to go through the electron transport chain and oxidative phosphorylation and produce the very vast majority of ATP molecules that can sustain energy production for hours, i.e. your marathon runners. Okay, so these are the stages of energy production. And again, we're going to go into them in a lot more detail on Thursday. Okay, all of that energy production from nutrients to ATP is called cellular respiration. All right, and here's a quick table that shows what we've talked about at the top. Stage 1 is what we talked about all last week, when we had our macromolecules, proteins, carbohydrates, and fats, and we broke them down into monomers. Proteins into amino acids, carbohydrates into monosaccharides like glucose, and fats into either glycerol or fatty acids. All right, so that much we've covered at length before. Stage 2, and this is just a table of what we just saw back here, but illustrated. At stage 2, we can do one of two things with all of these monomers. The monomers, we can either resynthesize them through anabolic pathways and build the amino acids back into proteins for structural repair. The glucose can get stored as glycogen for future storage if we want it to. And the glycerol and fatty acids can be synthesized back into triglycerides to be used later. Okay, so that's an option. But the other option is we can consume it. We can convert the monomers into ATP for fuel. And that's what these pathways, glycolysis, and then if that's not enough ATP, glycolysis feeds into the Krebs or citric acid cycle in the mitochondria. And if that's not enough ATP, then the chemicals are going to make their way down the line into the electron transport chain in a process called oxidative phosphorylation to make a tremendous amount of ATP for sustained activity. Okay? All stages of utilizing nutrients for the purposes of making fuel for the body. And then the last slide for today is on enzymes. A reminder, enzymes are something that cause a chemical reaction or they intensify a chemical reaction. We've talked about that many times. They're the exact opposite of buffers. Buffers minimize a chemical response or stop it from occurring. Enzymes cause a chemical reaction to occur. So when we're talking about metabolism and the conversion of nutrients into pyruvate and acetyl-CoA and other coenzymes and ultimately ATP, all of these are chemical reactions caused by enzymes. Okay? So we already know this underlying statement should be a real easy test question for you, that catabolic enzymes, catabolism, breaking molecules down, breaking lipids, carbohydrates, and proteins, those macromolecules down into monomers, is called chemical digestion. We talked about that all last week. None of you will get that one wrong on the test, I hope. Okay? most of our enzymes are protein-based enzymes. Okay, so most of them have a protein portion. And then this is where, going back to when I talked about vitamins and minerals, and I said that those vitamins and minerals bind to other nutrients to make them functional. This is where our protein portion of enzymes binds to a coenzyme like a vitamin or a cofactor like a mineral to activate it and make it a functional enzyme to allow for a chemical reaction. Okay? So that's it. We're going to pick up next time with phosphorylation, the very first grab of nutrients to produce ATP, and then we're going to proceed through all of the biochemical metabolic pathways. We're going to talk about the conversion of macromolecules from one type to another, like gluconeogenesis and lipolysis and all kinds of terms that many of you have never heard of. So please don't miss Thursday. Drop me your extra credit questions within the next 15 minutes so I can give you your extra credit. Have a great couple of days. And if there are any questions, I'll take them now. If not, we'll see you guys on Thursday at our normal time. Guys, don't forget, we have a lab quiz today. Lab quiz today, due at 8 o'clock. Okay? Many of you have taken your lab and you're doing an outstanding job. The scores have been phenomenal so far. So get those done today. Yes, questions?
I had the same issue again with it not allowing me to have the button to start the exam. I tried to do it twice. I reached out to the help desk, but I haven't been able to receive any assistance.
Okay. All right. Let me know.
To the point. Yeah, I get to the point, like when I sent you the last screenshot on the last exam, and
yes,
when I've done all the environment and stuff like that, it just does not generate the button for me to start the exam. And so I logged back out, redid it again, and it did it again. So I'm gonna try one more time when I get home, and then if it doesn't work, I'll just shoot you another email.
Oh, please do. Please do.
I had that experience last exam as well.
Okay. Yeah, I don't know what's going on, but it just will not. That green button to start won't populate.
Oh, okay. All right. If we're having a technology issue like that, by all means, let me know. Get me your information so that I know that, and I would give you guys tomorrow then to take it so that you have time to get on. The other suggestion is you could go to a public location. Again, I know that's not ideal by any means.
Yeah, that's why I'm heading to Starbucks right now, so hopefully it'll work from there.
Right. It sounds, without knowing anything about technology, it sounds to me like it's something to do with your device or your internet. But again, I don't know that factually. So let me know. If so, I'll wait. I'll open it for you tomorrow. You can get on with IT. Make sure that you get it resolved with IT help. Find out what the root of the problem is. Explain that this is a recurring issue, because obviously for the rest of the semester, problem.
Okay, thank you.
Okay, you're welcome. And any other questions today, guys? All right, outstanding. We'll have an excellent 2 days. Good luck on your lab quiz, and we'll see you on Thursday to really